Hello everyone and welcome back to PostNetwork Academy. I am Bindeshwar and in this video you will understand linear combination and spanning sets in linear algebra. These are key concepts and applicable in generative AI, deep learning and machine learning, especially for embeddings. So without further delay, let's get started. So let V be a vector space over field K. Then here a vector is a linear combination of U1, U2, Um if they exist scalars A1, A2, M, so that you can write V in terms of A1, or you can say that A and UI. Another alternative definition, you can say that V is a linear combination of U1, U2, these vectors if there exists a solution to this vector equation where x1, x2, these are unknown scalars and we will find it. So let us see an example. So suppose that we want to express V, that is in RQ, and we want to express V in terms of these three vectors. So we will write like this one, that is V x1, you can say that u1, that is x2, u2, x3, u3. So what we need to find x1, x2 and x3. So you will get three equations. Thereafter you can reduce it to echelon form and finally you will get the values x is equal to 2, y is equal to minus 4 and z is equal to 3. So here we can express V in terms of u1, u2, u3. Here means that is A means x, that is y, that is z. So V can be expressed in terms of these three vectors with scalars. Now we can also express polynomials in terms of other polynomials. Here we will express V in terms of P1, P2 and P3. The process is the same. So just we will find three equations here. First of all, what will you do? You will write like here, this one. This is basically V, that is x already, x1, u1 or p1 you can write here because that is polynomial. So p1, x2, p2 plus x3, p3. Now what we will find x1, x2 and x3. So here just if you compare coefficient of t square, t and constant, so you will get three equations, and if you solve, so we will get z is equal to minus 2, y is equal to 1 and x is equal to 3. So we can express V in terms of P1, P2 and P3 as given here. So here 3, that is x, y 1 and z minus 2, you can say that. So basically we need to find the scalars. Now we can also use alternate method and we can solve, but the previous method is general and you can apply for any vector space, that means for a polynomial and for others also. Now let us understand spanning sets. So if V is a vector space over field K, then u1, u2, um in V are set to span or construct, create if every vector in V is a linear combination of them. Means every vector in V that is a linear combination of u1, u2, then you will say that these vectors span vector V, vector space V. Now there are some points you should know. If span V, then if you add any vector that will also span V, but that must be from V. If it is UK is a linear combination of the others, that means it may be u1, u2. So if you remove it, so these vectors will still span. And third one, if zero vector you will remove, again all vectors will span V. Now let us understand with an example. So I am claiming that e1, e2, e3 that spans RQ, and see that what are e1, e2, e3. So these vectors. So using these three vectors, you can span any vector of RQ, any vector. So here ABC in RQ, so you can simply express V. Let us see an example. 5 minus 6, 2. So if instead of here 7, simply you can replace 7. So any vector can be construct using these three vectors in RQ. Again, also using these three vectors, we can construct any vector from RQ. Here, these three vectors cannot create or span all vectors of RQ. Let us see a counter example. 278 cannot be written as a linear combination of UI. You can check it. Now let us see spanning set for polynomials. So the same way these terms can span any polynomial expression of P and T vector space. So here it can construct. Now let us see spanning set for M2 cross 2. So what is the vector space M? That is 2 cross 2, means all 2 cross 2 matrices. So there are 4, and using these 4 you can construct any matrix of 2 cross 2. That means these matrices span any matrix in 2 cross 2 vector space, you can say that. Here suppose that an example 5 minus 6, 7, 8. So this matrix can be written as linear combination of e11, e12, e21, e22. So you can say that these matrices span M22. Here M22 is a vector space. That is vector space here already written. So hope you understood, and you will apply in your research, your projects. For more resources, you can visit website, YouTube channel, Facebook page, LinkedIn page, and you can also visit GitHub repositories for a code and projects. So hope you understood. Thanks for watching the video.